So no warm-up to start today. We just started right with our notes after checking homework. So homework tonight, you can see, is going to be on page 27, worksheet number 2, and also to finish up worksheet number 3. So we started today by talking about parallel and perpendicular lines, and really today's lesson is review from both Algebra 1 and Geometry. So in Algebra 1 and Geometry, you talked about parallel lines and what that means. We know they're two lines that never intersect. So if I'm visualizing parallel lines, I have these two lines that never intersect, and the reason that they never intersect is because they are angled the exact same. And if they're angled the exact same, that means that they have the same slope. So then perpendicular lines, you also remember, means that the two lines intersect to form 4 90-degree angles. So one at each part of the intersection point. So in order for lines to be perpendicular, their slopes are the opposite sign and reciprocals. And again, this is review. So for example, if the slope of one line is 4, the slope of the perpendicular, and that's the notation we would use using the perpendicular symbol, slope of the perpendicular would be the reciprocal 1/4, but the opposite sign, so -1/4. So using that information, we're going to write the equation of a line, and it does say in slope-intercept form. So because it's a slope-intercept form, I'm going to just start with slope-intercept form. Okay. And it's going to be parallel to this line and through this point. So if I'm looking at this line and I want to first figure out what the slope is here, I know, of course, that's 3. So I want the same slope because of parallel lines having the same slope. So I'm going to substitute 3 in for m. And then I know the point is xy, so I'll substitute 13 in for y and 2 in for x, and I'll solve for b. So I'm getting that b is equal to 7. So our equation is y equals 3x plus 7. Next example, make sure that gets in your notes. So this time we have this equation, and we have the slope I can see is 1/2. M is 1/2. We want the perpendicular line, so we want M perpendicular. So we're going to get the reciprocal and change signs, which would give us -2. And it's asking for, again, slope-intercept form. So I'm going to go ahead and substitute -2 in for m into y equals mx plus b. And then I'll substitute the coordinate point in for x and for y. So -4 equals -2 times -3 plus b. Solving that for b, -4 equals 6 plus b. So subtracting 6 from both sides, b is equal to -10. So our equation y equals -2x minus 10. Okay, and that should be a pretty easy, quick review. So the next one, this time we want the equation of the line that's parallel to the y-axis and contains the point 7, 12. Well, we don't have an equation, and we don't have, so because we don't have an equation this time, we don't have a slope. So this one's easier just to visualize. So if it's talking about the y-axis, then maybe it would be helpful if I could see the y-axis. So I drew myself a coordinate plane, and I'm just gonna graph this point 7, 12. So I'll graph that point. Now I could go over 7 and up 12. I'm just gonna approximate it. We'll just put it about there. So if I put 7, 12 there, now I want a line to be going through that, and the line that I draw through that point has to be parallel to the y-axis. So remember, this is our y-axis. So if we think about that a little bit, we can see that the line is going to be a vertical line. That's the only way it's going to go through that point and be parallel to the y-axis. So there's my line. So if it's through that point and a vertical line, we remember from our lesson the other day that vertical lines are x equals a number. And then I can see by my sketch here that x has to be 7 because the x value of that coordinate point is 7. So that's my equation. Didn't really require any work, just had to kind of visualize and see that a vertical line is parallel to the y-axis, and so it's at x equals, and then the number that x equals is 7 because that's the x part of the coordinate point. Last example. So this time we're going to write the equation of the line in standard form that's perpendicular bisector of the line segment with endpoints 3, 19, and -2, -11. So a couple things that we have to remember here. We have to remember what a line segment is from geometry, and we have to remember what a perpendicular bisector is. So we're going to just visualize this a little bit. So if I were to plot -2, -11 on an xy coordinate plane, we know that's down 2, or left 2 and down 11. And if I plotted 3, 19, that's right 3 and up 19. Well, that would give me a diagonal line segment. I'm going to just flatten that line segment out for demonstration purposes here. So I'm just going to draw a line segment, which is basically the line segment I would have from those two coordinate points, but I'm just going to flatten it out so it's easier for us to visualize what perpendicular bisector is. So even though my line segment really would be like that, and this is -2, -11, and this is 319, I'm just going to label it on this one, again, just for demonstration purposes here. So -2, -11, and 319. So now that I have that line segment, I need to remember what perpendicular bisector means. Well, we remember perpendicular because we already talked about that a moment ago. We know that if we have a line that's perpendicular to this line segment, it's going to be intersecting the line segment to form 90-degree angles. But it's not only just perpendicular, it's also a bisector. So the term bisector, if you recall, means it's bisecting. Well, bisecting, another word for that, is cutting in half so that we form two congruent line segments. And if we have two congruent line segments formed when we have this bisect happening, that means that the line that's bisecting this line segment is going through the midpoint of this line segment. Okay, that midpoint should sound familiar, meaning the middle of this line segment is called the midpoint. If we have a line that's going through that midpoint, that would be bisecting the midpoint. So if this line is both perpendicular and going through the midpoint, then that's the line that we're looking for. So I'm going to try and draw that. I'm looking to about the center here. I'm going to put a midpoint there, and I'm going to draw a line that not only is going through that midpoint, but is perpendicular to the line segment. So that would be the perpendicular bisector. And again, we just flattened this out and made it a straight horizontal line, but the same would be true over here. It would just be perpendicular and going through the midpoint. Okay, so now we have kind of an idea of what we're looking at or what we're looking for. So we need to think about how we're going to go about doing that. Well, first of all, we have 2 points and we can calculate the slope of that line segment. And if I have the slope of the line segment, then I can use that to get the slope of the line that's perpendicular to it. So let's start with that. So we're going to start with the slope of the line segment using difference in y divided by difference in x. So 19 minus -11 divided by 3 minus -2. And I'm going to simplify that. So 19 minus negative 11 is 19 plus 11, which is 30. And 3 minus negative 2 is 3 plus 2, which is 5. So 30 divided by 5 is 6. Now that's the slope of the line segment. We want the slope of the line that's perpendicular to it. So we're going to get the opposite reciprocal, which means negative 1/6 is the slope of the perpendicular line. So next, we're going to figure out what the midpoint of this line segment is. I not only need a point to go with the slope to come up with the equation for the line, but I specifically need the point to be the midpoint. So you have to remember how you calculated midpoint. Well, you learned that the midpoint is equal to, basically you're just finding the average of the x's and the average of the y's. So you're adding the x's and dividing by 2, and you're adding the y's and you're dividing by 2, and that will give you the midpoint. So if I do that with these two coordinate points, I'm going to add up -2 and +3 and divide that by 2, and I'm going to add up 19 and -11 and divide that by 2. So 3 minus 2 is 1, 1/2 is the x part of the midpoint, and 19 plus -11 is 8, and 8 divided by 2 is 4. So we know that the midpoint is located at 1/2 4. Okay, so that's 1/2 4 is that point. So now we have a point, and now we know the slope, so we can come up with the equation for this line right here, okay, which is the perpendicular bisector of that line segment. So we could either use point slope or slope intercept to get our equation and then transfer it over to standard form. It doesn't really matter which. Since point slope is newer to us, let's use that one just to get some more practice. So remember y minus y1, and remember the point I'm using is the midpoint, 4, is equal to slope of our perpendicular, -1/6, times the quantity x minus x1, which is -1/2. So that's our equation in point slope form. It did ask for standard though, so I'm not finished. I need to distribute the -1/6. And negative times a negative is a positive. 1/6 times 1/2 is 1/12. So now I'm going to get the x's and y's together and the numbers together. So I'm going to add 1/6x and add 4 to both sides. So 1/6x plus y is equal to, I'm adding 4 onto 1/12. So I have 1/6x plus y, and I'm thinking of 4 in 12ths. Of course, that's 48/12ths. So 48/12ths plus 1/12 gives me 49/12ths. Now, I know that that needs to be in standard form, so I need to get rid of those fractions. So I'm looking at the denominators, 6 and 12. The least common multiple is 12. So I'm going to multiply both sides of the equation by 12. And when I do that, 12 times 1/6, 12 divided by 6 is 2, 2x. 12 times y is 12y. And the 12s cancel out here, so I'm just left with 49. So 2x plus 12y is equal to 49. And that's the equation for the perpendicular bisector of the line segment. Okay, that's it for the notes today. So homework for tonight is page 27 to finish that up. Worksheet number 2, complete all of that. And then worksheet number 3, which was assigned a couple nights ago, part of it, you're going to finish that worksheet. I will tell you that worksheet 3 has both a front and a back. So when I say finish worksheet 3, I'm talking about both sides. Finish up the front side and then continue on to the back and finish that as well. And that's your homework for tomorrow. Also to let you know, you do have a 2-day test coming up next week on Thursday and Friday, one day being no calculator and the other day being with a calculator. And that's coming up next week on Thursday and Friday.